Motion rest and motion rest. An object is said to be at rest if it does not change its position with respect to its surroundings with the passage of time. Motion. A body is said to be in motion if its position changes continuously with respect to the surroundings, or with respect to an observer, with the passage of time. Rest and motion are relative terms. Types of motion on the basis of dimensions. One-dimensional motion. It is the motion in which the position of the object changes only in one direction. In this case, the object moves along a line. For example, motion of a train along a straight line, freely falling object under gravity, etc. Two-dimensional motion. It is the motion in which the position of the object changes in two directions. In this case, the object moves on a plane. For example, projectile motion. Three-dimensional motion. It is the motion in which the position of the object changes in three directions. In this case, the object moves in a space. For example, a bird flying in the sky. Distance and displacement motion is related to change of position. The length traveled in changing position may be expressed in terms of distance, i.e., the actual path length between 2 points. Distance is a scalar quantity, which has only a magnitude with no direction. The direct straight line pointing from the initial point to the final point is called displacement, change in position. Displacement only measures the change in position, not the details involved in the change in position. Displacement is a vector quantity, which has both magnitude and direction. The displacement can be zero, even if the distance is not zero. For example, when a body is thrown vertically upwards from a point on the ground, after some time it returns back to the same point, then the displacement of the body is zero, but the distance traveled by the body is not zero. It is 2h if h is the maximum height attained by the body. Similarly, if a body is moving in a circular or closed path and reaches its original position after one revolution, then the displacement in one revolution is zero, but the distance traveled is equal to the circumference of the circular path equals 2 pi r if r is the radius of the circular path.